Fine.
Yeah, it's good now, sir.
Design principles with respect to, so in the last session, just I was discussing, right? Configuring block size and replication, right? Configuring block size. Okay, I was just saying like, what is the criteria followed while selecting the slaves? So 4 steps criteria and configuring block size and replication. So go to the Hadoop installed folder and just go to the hdfs-site.xml file. In that XML file, just write this property, right? 2 properties. So dfs.block size and replication. By default, 3 times replication, but you can increase that replication or decrease the replication based on the sensitivity of the data. Design principles with respect to replication, right? Okay. Fine. I got some couple of queries here. So here. Is that compulsory? Is that mandatory? That mandatory that all the slaves should have, is that mandatory that all the slaves should have the same hardware configuration, the same hardware configuration? Is that mandatory that all the slave machines should have the same hardware configuration? And one more. Okay, no, they can go with different configurations, right? One more. Is that mandatory that all the slaves should have the same default block size? All the slaves should have. Is that mandatory that all the slaves should have the same default block size? What's the answer? Yes. Yes. All the slaves should have the same default block size means yes. Yes, we need to have the same default block size. So what is the problem if you maintain different block sizes? So even though your data is divided into small blocks, so some of the blocks cannot be okay. Even though you have got many slaves, some of the slaves won't be supporting to accommodate the blocks. Okay. So I'll be discussing both the architectures, like the old Hadoop old architecture and this latest architecture. Both I'll be discussing so that if anybody are going as experienced, you can just check that how it was previously and how is the new architecture. Hadoop architecture. Storage architectural components. Storage architectural components. Processing architectural components. So Hadoop architecture, storage architectural components, and processing architectural components. Okay, fine. If you observe this diagram, right? Hadoop is meant for both storage and processing, right? Storage and processing. For storage, HDFS. For processing, MapReduce. For storage, HDFS, and for processing, MapReduce. So what are the, okay, for example, here three things we see. For storage, right? Name node, data node, secondary name node. So yesterday I was just discussing that replication and fault tolerance in single master and multiple slaves, right? In this manner. So here, T1 task, T2 task, T3 task assigned to slave 1, slave 2, and slave 3. T1, D2, T3 assigned to S1, S2, S3, right? 3 tasks are executed by the 3 slaves parallelly. 3 tasks are executed by the 3 slaves parallelly, right? Suddenly, if any one slave goes down, 3 tasks are executed by the 3 slaves parallelly. Suddenly, if any slave goes down, the task can be assigned to any of the available slave. But if the master goes down, that's we have got secondary name node. We got what? Secondary name node. And for MapReduce, right, we have got like a job tracker, task tracker. For processing, like job tracker, task tracker. Storage architectural components. Or HDFS architectural components. HDFS architectural components, right? And this is processing architectural components. Okay, first we discuss about this name node, data node, and secondary name node. What exactly happens within the name node, data node, and secondary name node, right? Okay. Okay. Name node. Observe this first. If we discuss what exactly happens within the name node, right? Name node. Assume like f1.txt 192 MB. How many blocks? Number of blocks. 192 by 64. Like we have got like 3 blocks. B1, B2, and B3. How these blocks are stored across the slaves? single master and multiple slaves. Okay. Slave 1, slave 2, slave 3. So B1 stored here, B2 stored here, B3 stored here, right? B1, B2, B3. This is the name node, right? Which stores the metadata information, data about data. So this f1.txt divided into how many blocks? B3 and stored in slave 1, S2 and S3. So here, okay. So here blocks, slaves, here blocks information, slaves information, right? And here this B1 stored here, B2 and B3, right? B1, what is the memory location address? Assume that this is the memory location address. This is the memory location. This is the memory location address, right? These addresses, right? Physical memory location address. Retrieving f1.txt file. If you want to retrieving f1.txt file, right? If you want to retrieve f1.txt, nothing but b1 plus b2 plus b3. Means we need to access that physical memory locations, right? Okay. So here the blocks, the slaves, and the physical memory locations. Data node stores the slaves, slave nodes, data nodes are the slave nodes, stores the blocks and the physical memory location addresses. Now, based on this diagram, now try to say what are the responsibilities of name node. Name node responsibilities. Based on this, right? Now try to say to store the physical memory locations of the blocks of a file. To store the physical memory locations to store the physical memory locations of the blocks of a file. To combine the physical memory locations to combine which physical memory locations? To combine which physical memory locations of the block so that the file can be formulated. To combine which physical memory locations of the block so that the file can be formulated, right? Okay. Okay. Stores the metadata information. It won't store the actual data, but it stores the metadata information. That is data about data. Next, right. Data node responsibilities. Data node responsibilities. Data node responsibilities is to store the blocks of a file. To store the blocks of a file. That's okay. To store the blocks of a file. See, processing the data won't be taken care by this data, but we have got some more processing components are available, right? Data node just stores the blocks of a file. The number of data nodes depends on the volume of the data. Okay. So here name node, data node, that is fine, but we didn't discuss anything about the secondary name node, right? Secondary name node. Secondary name node. If name node is down, if name node is down, then the entire cluster will be down. Then the entire cluster is down. We cannot make any storage or processing operations. We cannot perform any storage or processing operations. So in this case, so whenever name node is down, then immediately secondary name node, SNN. So secondary name node comes into picture. Secondary, okay. Secondary name node responsibilities. Secondary name node responsibilities. The same as name node, right? Same as name node to store this meta, these three things. stores the metadata, that is the data about the data, right? Okay. Secondary name node is not 100% backup node, is not 100% backup node, 100% backup node to name node. Secondary name node is not 100% name node. Can read, write, and update. Name node can read, write, and update, but secondary name node can only read. So name node can read, write, and update, but secondary name node can only read. So to understand this, what happens within the secondary name node, first you need to understand what happens within this name node. Observe this diagram once. Every node, think this is a name node. This is a name node, right? Every node in the cluster is going to have local file system, Hadoop distributed file system. So if you take a file f1.txt, divide into blocks, right? Divide into blocks. These blocks are stored. These blocks also metadata also stored in the form of this array. Metadata. Talk about this metadata is stored in the data nodes, but here metadata also stored in the form of blocks. Metadata also stored in the form of blocks. So this is what temp folder. There is a temp folder here, okay, in local file system. So metadata stored in the form, metadata also stored in the form of blocks. So this metadata also stored in this metadata in a temp folder in a timely manner. In a timely manner, copied into two special files. Copied into two special files. Observe here, metadata also stored in the form of blocks. It's also stored in temp folder. From there, in a timely manner, copied into two special files. FS image and edits. FS image and edits. Timely manner means hourly, daily, weekly, monthly. Copied into two special files, FS image and edits. So FS image and edits. Here FS image edits. So from a temp folder, copied into this, right? So metadata also stored in this name node in the form of blocks. From there also stored in the temp folder, and the temp folder in a timely manner copied into files like FS image and edit set in a timely manner. So, okay, now comparing this name node and secondary name node, right? Comparing this name node and secondary name, we can observe. Okay. Now, see this difference, observe this. So before this, okay, 1 second. Morning 7 to 8. Morning 7 a.m. to 8 a.m., right? Name node running. 8 a.m. to 9 a.m., right? 8 a.m. to 9 a.m. Name node running. At 9 a.m., for example, assume that name node down from 9 to 10, right? Secondary name node is running. 10 to 11. For example, at 10 a.m., name node up. Now observe this. This is name node. This is name node, and this is what? Secondary name node. Every node in that you are going to have, see, local file system, Hadoop distributed file system. Local file system, Hadoop distributed file system. Okay. F1.txt, blocks. Metadata also stored in the form of blocks. Metadata also stored in the form of blocks. It's also stored in the temp folder. Okay. In a timely manner, copied into this FS image and edits. FS image and edits. For example, morning 7 to 8. Okay, fine. 8 to 9, it's fine. And 7 to 8, 8 to 9. But if at 9 o'clock, it's down. Then from here, from FS image and edits, secondary name node takes that information and just from 9 to whatever 9 to 10, it stores in the temp folder. from 10 to 9 to 10. At 10 o'clock when name node is up, it is going to copy this into this. Okay. Again 10 to 11, it's going to update. This is from 9 to 10. So here name node and secondary name node. Name node can read, write, and update, but secondary name node, see into FS image and edits, name node can read, write, and update, but secondary name node can only read, cannot write or update. Fine. So here, if you observe this example, right? A file, if you take in Hadoop file, data is stored in the data node. But here I'm talking about name node. Metadata stored about that data, data about data. Metadata also stored in the form of blocks. And that metadata also stored in the temp folder in local file system, that is Linux. So in a timely manner, the metadata copied into two special files called as fs image and edits, right? Fs image and edits. Okay, this is what name node. Okay, if I take this 7 to 8 name node running, 8 to 9 name node running, suddenly at 9 o'clock name node down, again from 9 to 10 secondary name node running, again at 10 o'clock name node is up. Okay, for example, the metadata also stored in the temp folder in a timely manner, it's copied into this fs image and edits, fs image and edits, right? Okay, fine. Fs image and edits, fs image and edits, right? Okay, fine. So at 7 to 8, okay, 8 to 9, okay, at 9 o'clock name node down. So to process, so secondary name node comes into picture, right? Secondary name node takes the data from this fs image and edits, and from 9 to 10 whatever data generated will be stored in the temp folder. And at 10 o'clock when name node is up, it is going to take the data from there and updates in fs image, so that it will have the entire information during its presence and its absence. During its presence and during absence, it is going to maintain the entire information, right? Okay. Okay, yes. Now, processing our textual components. Job tracker, just now I said that job tracker and a task tracker. Job tracker, okay, 1 second. Job tracker resides on the name node. Resides. Task trackers resides on the data nodes. Resides on data nodes. Job tracker resides on name node. Task tracker resides on data nodes. Observe this diagram once. Yes, 1 second. Okay. Excuse me. So this is my master node. These are my slaves. These are my slave nodes. Slave, nothing but data node 1, data node 2, data node 3. Here this is the name node. So within this name node, you have what like job tracker available. Here task tracker 1, task tracker 2, task tracker. So here job tracker, single job tracker, multiple task tracker. Job tracker assigns the task T1 to task tracker 1, T2 task to task tracker 2, T3 task to task tracker. So who is going? These 3 tasks are executed by these 3 task trackers parallelly. Who is going to execute the tasks? Task trackers. Who is going to assign the task? Job tracker. So number of task trackers depend. Okay, here I'm writing. Job tracker responsibilities. Who is going to assign the task? Everything task related, everything taken care by job tracker. Task assignment. Task assignment. Second is like load balancing taken care by this job tracker only. Balance, load balancing, fault tolerance also. If multiple tasks are running parallelly by multiple task trackers, Suddenly, if any slave machine down, the task of that slave is assigned to any of the available task trackers. So these are job tracker responsibility, fault tolerance also. Okay. Task tracker responsibilities. Task tracker responsibilities. What are the task tracker? Executing the tasks. Given by job tracker. Executing the tasks given by job tracker. Giving acknowledgement to job tracker. Job tracker sends heartbeats. Job tracker sends 1 second. Here I've got some couple of queries. How this job tracker comes to know this particular slave is down? Anyone? How job tracker comes to know that particular slave is down? There will be some. Okay, 1 second. We have got some heartbeats, right? Heartbeat signals. Heartbeat signals between them based on these heartbeat signals. Okay. So in the later we have got now in the later start lecture we'll be discussing like we have got node manager, resource manager. We have got like the resource manager, resource scheduler, node manager, application master, application manager. Okay, we have got many components. Job tracker since job tracker sends heartbeats to hearts. Okay. Sorry. So what is the task tracker responsibilities mean? Sends heartbeats for every 3 seconds. If these heartbeats are missing, then job tracker thinks the particular task tracker is down. Okay. So I have got some queries here. Okay. Who divides? Who divides the job into tasks? Who divides the job into tasks? Who divides? So first, before this, Who is the master? Who is the master? Observe this diagram, right? Observe this diagram. This name node, this is job tracker, this is the master node. Name node is the master for storage, job tracker for processing, both in the master. Who is the master for storage? Who is the master for the storage? Name node, right? Okay. Who is the master for processing? Who is the master for processing, right? Job tracker. Master for processing means job tracker. Master, I'm saying. Get to all this. Who divides? Who divides the job into tasks? And assigns to various task trackers. And assigns to, okay. Who stores the data blocks into slaves? Name node. Who stores the data blocks into slaves? Who is responsible for storing the data blocks? Who stores the okay, who stores the actual data blocks? Who stores the actual data blocks? Data node, right? Fine. Who stores the actual data blocks? Data nodes. Who is responsible for Who is responsible for processing the tasks? Yes, right. Task track. Who are responsible for processing the task? Task trackers. Who takes care of faults? Who takes care of fault tolerance? Fault tolerance means if a particular data node, if a particular who are assigning the task to other task trackers, assigning the if any fail any for example slave is failed, the task of it need to be assigned to any of the other task trackers. Who takes care of fault tolerance means job tracker. Job tracker only takes care of the entire processing related. Okay. Data node for storing. Okay. Who is responsible in name node failure? Who takes the responsibility in name node failure? Secondary name node, right? Who takes responsibility in name node failure? Who takes responsibility after name node failure, right? Okay. Secondary name node. Who is responsible in maintaining the metadata? Name node, right? Name node. Okay. So understood, right? Okay. Fine. There is some concepts like speculative execution, speculative job, speculative task. What do you mean by speculative execution, speculative job, speculative task? I'll be discussing those in the next session, right? Okay, fine. Fine. So Monday to Friday, right? So tomorrow there won't be any session. That is Saturday. So we'll meet again on Monday. So more discussion on this. So Monday or Tuesday, I'll be just briefing you about the software, right? So Monday I'll be just forwarding to your mail IDs and I'll be demonstrating about the software. And I said before I go with the actual practical that, but I'll be just discussing the basic Linux commands, LFS commands before we go with HDFS commands, Hadoop distributed file system commands, right? Yes, yes. You want all this? Okay. Fine. Yes, yes. Yes, yes. Monday, okay. Monday the link is going to change, right? Monday, today only actually supposed to change, but okay. One more. But observe here, 1 second. You'll be getting this kind of link. 1 second. I got it. You people also should have gone, right? Okay, 1 second. Inbox. So folder share. Sorry. So you'll get a folder, right? Folder, shared folder you are going to get. In the shared folder, you'll be getting all the what is that? Up till now, what all that links, video links, right? Everything you are going to get in that, right? So everyone got the videos, video links. Can anyone please come? Have you received that video links? Last three videos. Okay. So okay. 1 second. Fine. Okay. I'll just the online team to just share the videos to you. Okay. Later on Monday or Tuesday, we'll have a group. And okay, fine. So we'll meet on Monday again. Continuation of the same time, right? We'll start 5 o'clock, but we'll start by 5:15, right? It's daily like at 5 o'clock. We'll start by 5:15. Okay. So I'll stop here. We'll continue on Monday. Fine. Okay.